Alright, this is 2016 Unit 1 Module 3. Data flow diagrams are commonly used in the process of software development. State the purpose of a DFD in the software development process. A data flow diagram is to show the flow of data within an information system where it is stored, processed, and disseminated to. Right, yeah, to show the flow of data within our information system where it's stored. Right, yeah. Same three symbols using a data flow diagram. You have a rectangle, an oval, and you have a rectangle is an external entity. A oval is a process, and I don't even know what to call a storage. A rectangle with a square, rectangle with square. Let's just draw it. Yes, yeah, rectangle with a square is a data store, and then an arrow is a data flow arrow. So external entity, rectangle, the oval for this, or you could get them let's have a kind of rectangle with a square with a oval on top of it, with a half a circle on top of it. A data store is usually that, and an arrow is an arrow. Any three should work. I recommend you just draw them one time. Fast food ordering system involves a sales clerk entering the items and quantity ordered by a customer. This results in the calculation of the total cost of the order by printing of a receipt. The receipt is given to the customer and the sales database is updated. Draw the context diagram for the ordering system above. Alright, so let me see if I could get the sales clerk as an external entity. Then we have the items and quantity, that is two pieces of data. The receipt is a piece of data that's given back to the customer, and there is a database that is updated. Well, there is a database. Well, a context diagram not really supposed to have data stores, but for some reason in these questions they have data stores as context. So we'll just put in. So we have a sales clerk sends items and quantity that goes into a process. The process is called calculate total, and it calculates the total and sends a receipt to the customer. So the customer is an external entity, and then well, this is receipt. You gotta make sure you label everything on our data flow diagram, right? And the sales database is updated, so it will send the order info, and we'll put that in the database called sales. Alright, that should be a context diagram. The receipt is given to the customer and the sales database is updated. Full calculation of the total cost of the order and printing of a receipt. The receipt is given right here. So that's basically what we have there for 8 marks. Fairly straightforward. Part B, many tools are used during the analysis stage of the problem solving process. There's 3 tools that may be used during the analysis stage. That's questionnaires, interviews, and observations, and then you have review of documents. Straightforward. Alright, outline one advantage of using each of the tools listed in B part 1 above. One advantage okay, so let's go questionnaires. Questionnaires, they give you discrete data. Discrete data can be collected because closed-ended questions are used. It is easy to analyze. Right, then I wrote too much, but yeah, I feel like I wrote too much. Let me use the space out better, because I had to do 3 of them. Right, so you go across there because open-ended questions are used. It's easy to analyze. See how I'm doing this, but it's easy to I have enough space. Okay, I'll take out the discrete data, and I put it is easy to analyze because closed-ended questions are used. Alright, yeah. Interviews, they can give you the option to gather more data by asking deeper questions, deeper open-ended questions. Alright, then in observations, they give you the ability to they give you the ability to view the system firsthand and see how things really work. yeah, review of documents will be basically you get to see what is actually collected, and you'll be able to get a flow of how the data is transmitted through the system. All right, discuss the importance of the review stage of the problem solving process. Okay, this stage gives the developer an opportunity to get feedback from both the system and the users. It allows them to find / pinpoint the types of errors that exist and types of errors exist and what needs to be fixed or upgraded in the future. Right. Number 6. All right. Programming is a process and involves a number of tasks. Designing algorithms responsible has identified 2 ways of representing an algorithm other than pseudocode, flowchart, narrative, and actual programming code. Any of those 3 should work. Outline 2 advantages of using pseudocode to represent an algorithm. 1, it closely resembles actual code, so the programmer would not have to spend too much time translating the code to programming syntax. 2, it can give a normal person, a non-programmer, it can give a non-programmer a chance to understand the program a bit, since English-like statements are used. Yeah, that's cool. Yeah. Outline 2 advantages, disadvantages of using pseudocode to represent an algorithm. A disadvantage of using pseudocode to represent an algorithm would be 1, some of the terms used may be hard for non-programmers to understand. Example, for and while loops. 2, some programming languages cannot, we could say very long programs or very long algorithms may seem too long or complex, or may get too long or complex and become very difficult to understand. Example, functional algorithms. When you have a lot of functions, it will take kind of long sometimes to represent in a pseudocode take kind of long. Alright, the figure below shows an algorithm. N is equal to 0, n is equal to 2, total is equal to count, x is equal to 0. Right, for x is 1 to 3, read, blah blah blah. Still 2 control structures that are used in this algorithm. Alright, there is there's always sequence definitely used. There is selection, and there is also iteration. Any one of these will go, no problem. In the space below, write the part of the program that represents one of the control structures. Alright, so we go with selection. Selection will be if n1 is greater than n2, total is equal to total plus n1. But you could have also put the for loop here, and I don't know, write out, it would be kind of weird to write out this whole thing here for the whole for loop, but that would be the for loop part. And if you want to go with sequential, you could write out this part here, because that's sequential to show one after the other. So whichever one you choose, but I think it's easier to write the selection one because it's very short. All you need to show is the if and first statement. Study the algorithm and use it to complete the trace table below. Alright, so n1, n2, total, all those things start at 0, but they're not starting from 0 here for these numbers. They're starting from 2 and 3. So therefore we're basically looking at from the loop part. So x is 1, so the loop starts here. So x will be 1, 2, and 3, right? I guess is the value of x changing anywhere inside it. Nope. Alright, so x is definitely going to go 3 times because x is part of a for loop. So that's 1, 2, 3. Read n1 and n2. They gave us 2 and 3 as the things that come in. Good. So let's see if we get a 2 and a 3. 2 and a 3. Is 2 greater than 3? No, it's not. Therefore, we will not do what is inside the if. We will exclude what the if says to do, and we'll just loop again. So the value of total will stay as 0, and the value of count will stay as 0. So we'll put 0, 0 here, because they never change. And then in the next line, we get n1 as 5, but it didn't tell us what n2 is. So in the next line now, n1 comes in at 5, but n2 didn't come in as anything. Or we have to guess what n2 will be if the total end up becoming 5. So if the total end up becoming 5, total is equal to total plus n1. That means n2 would have to come in as 0. And then 5 is greater than 0. Therefore, total is equal to 0 plus 5. Right, so we get the total there as 5. So n2 would have to come in as 0 for that to be accepted. And then count would go up to 1. Count is equal to count plus 1. So count would go up by 1 here. Alright, so count starts off at 0 and 0 plus 1 will give us 1. Nice. Then we go again. Now we have to figure out that what n1 is going to be if we're going to get 12. So 5 plus how much is going to give us 12? 5 plus 7. So that means n1 will have to come in as 7. So if we got 7 and 0, then we're going to say if 7 is greater than 0, then it will be total is equal to 5 plus 7. 5 plus 7. So that will give us 11. And count should go up to 1 plus 1, which will be 2. Do they have a 2 there? Nope. Count will go up to 2. Right, that would be our trace table there. There's some deductions that you have to do, but should be able to manage. Explain the function of this algorithm. These are the questions where you have to kind of make sense of what they're trying to do. Find the total of all values if the first number is greater than the second number. Okay, so we'll put, is there any pattern? 5 and 12? Nope. Okay, so find the total. Sorry, I put 3 2 numbers. 3 2 numbers, and find the total of 3 2 numbers. No, read 3 sets of 2 numbers because it's a loop that's going 3 times, right? It's a loop that's going 3 times here. So read 3 sets of 2 numbers and find the total of the numbers where n1 is greater than n2. A count of every time an addition takes place.